Hello, today I'm going to show you an investigation called Evaluation of Differences in Explorers Medium for Steam Injection Processes with Laboratory Tests developed by who's speaking, I'm Fernando Muñoz Navarro, with, with the help of a teamwork. In the investigation, as an introduction during the coating processes in the petroleum industry, there is extraction from samples from the depth, but this extraction could be incurred or could be related with elevated expenditures, complexity during extraction, handling difficulties, and preservation problems due to all the process that involve like getting an real sample from the depth. So that's why during the processes in the industry, the synthetic porous media option has been evaluated in different with different propositions, and this is why they have lower prices, property similarities, handling facilities, and reproducibility. And for that reason, we made like an investigation for knowing which are the best practices or which are the most important practices for making these aesthetics for use media in the industry for oil and gas. So during this investigation, we observed that the Portland cement with silica gel, the sodium silicate, and Sandpacks were three of the main processes or methodologies for making these synthetic porous media. So that's why we develop and processes and methodology for making this representation of a core from the depth using a synthetic source media by these methodologies and techniques. So the first one is the cement as binder material. For this one, where the concrete hardening is related to the hydration reaction. This appears when the water touch the concrete and could be obtain different properties. For example, one of them is the heat resistance, but with a lower 150 Celsius degrees. They have low resistance. However, this is a concrete normally. However, when you add a silica source, the heat resistance could be higher and could get stronger and could achieve a heat resistance higher than 150 Celsius degrees. For this purpose, we made an experiment that was made with water, Portland cement type 1, and silica gel, and also Ottawa sand with a mesh 20 to 40. And these all materials were manually mixed in a relationship 30 to 70 and was mixed manually until paste. Once the paste texture was achieved, they was placed into a core holder and was put it over 1,200 psia for pressure at temperature for 80 Celsius degrees by a residence time for 6 hours in an oven. So once the material was obtained, we made like an initial test results, the special one, the integrity tests. However, the test with like USC and absolute permeability observed that there was no an integrity test. So that's the reason that we developed an experimental design, making a variation in the binder sand proportion, the hydration ratios, and the silica ratios, and also the presence of an agent that is CaCl2. And this ratio was a mass ratios, and the ratio of the CaCl2 was calculated with related to the cement quantity. So once the design was made, we obtained these parameters that was the principal was porosity and permeability due to there was the intention to recreate or make a reproduction for the the processes or the cores that are located in the MMBA basin field, in a field in this basin in Colombia. And the problem was that during this or by this methodology was achieved great porosities and low permeability. However, the permeabilities achieved or obtained in the real sample in the field is between 780 to 1000 millidarcies. So that's why we passed to the second methodology, that was sodium silicate as cylinder material. And for this part, have to be made a previous experiment that is developed to obtain the critical solubility temperature. And the experiment is made to heat and calculate the mass balance, and also making a dissolution test for knowing if the solubility or the temperature that was put it over the sample is the critical one, or have to be a new test for knowing the real critical solubility temperature. So in this case, there was achieved that 300 Celsius degrees was the critical solubility temperature for the samples developed in the laboratory. The preparation of the samples were made with an Ottawa Sand 82-100 mesh. Also, the addition to sodium silicate, once we know the critical solubility temperature of this material, and was subjected to 5,000 psia for pressure, 300 Celsius degrees for temperature during 6 hours of residence in an electrical oven. About the integrity test, the samples were placed inside water, and the first day there was no reaction, and there was not disintegration from this test. However, up to 5 days, the samples get dissolved into water, and also get lost its integrity test. So that's why a temperature of 300 Celsius degrees is not the critical solubility temperature. However, a higher temperature could make like a lower core resistance for the in the UCS test. But in the literature, there was obtained that sometimes the use of kaolinite could help in this core resistance. However, this sample or this clay make like a problem, and the problem is that the samples that have this kaolinite appears or have a low permeability, and there is not the intention of this experiment or this design. So that's why we continue to the other one, that was the Sandpack. About the Sandpacks, design could be obtained by two ways principally. That is the artificial way, or from outcrops or formation samples from cores. And once the sand was obtained, have to make like a processes, for example, the milling, the washing, the drying, then was sieving and vibrated inside the core holder for making the Sandpack. About the preparation or design experiment that we developed was using Ottawa Sand to a mesh 80 to 100, then was placed by section while vibration was applied. And then once the sections was getting the top, for example, each section could be a height of 10 centimeters. We make the sample that was passing a current of dry air through them for making all this process of drying. So about the computed tomography or the integrity test that was made to this Sandpack, or this process, was a computed tomography inspection, and was using a process or an equation for knowing the density bulk of this sample. As you can see, we can find the porosity and using the density of the grain. In this case is Ottawa. Ottawa is made around 19% of silica. So is the density of the grain 2.65, and the density of the fluid, in this case, the fluid that was passing by through the core was air. So this is why we use this number for density of the fluid. Once we obtain the porosity, we can see that there is a variation about the property around this, like this all core. So that's why we obtain, we suggest to make a degree of sample heterogeneity that was developed by Mendieta Penagos in 2017. And this degree of sample heterogeneity could classify into low, intermediate, and heterogeneous sample. So in this case, using the process obtained by the statistic from the density bulk, we can obtain that there was a deviation of 0.01, a coefficient of variation of 0.040, and the coefficient of heterogeneity, there was about 5.21. That means that they have a degree of heterogeneity of 7, and the heterogeneity classification is an intermediate heterogeneity. Once this sample was made, there was suggest another experimental designs. In this case, for knowing how the pressure could affect the porosity. So in this case, there was used the sand with a mesh of 80 to 100 mesh. A confining pressure, the lower one was 14.7, and the higher one was 1,500 psia, per pressure of 14.7 and 500, and the porosity values obtained was 36.7% against 26.4% when the higher pressure confining and pore pressure was applied. So this is a variation for around 30.1% between one and another. So that means that there is a reduction in the porosity when the confining pressure is applied, and the pore pressure also have been represented. Also was made a investigation related with the mesh side effect over the other properties. In this case is the porosity and absolute permeability. So about this, we make a variation in the mesh size. So it's a mesh, the first one is 80 to 100, and the second one is 60 to 800. So the length and the diameters of the sample was made the same, and the variation of this is that there is porosity or higher porosity value with the 60 to 80 mesh, and that does mean that the bigger grains could achieve a bigger porosity into this system. And about the permeability happens the same. There is like a permeability of 300, around 3,000 millidarcies. So in this case, the use of Sandpacks give great porosities and great permeabilities that are required for making a representation for this field of the Magdalena Basin in Colombia. So the porosities that we are trying to obtain are between 25% to 28%, and the permeability are around 780 millidarcies to 1,000 millidarcies. So the Sandpacks was the principal methodology that we use to develop these processes. So about the conclusions, the permeability and porosity properties obtained from samples made with Portland cement cement and silica gel do not exceed values of 32% and 40 millidarcies respectively. Therefore, there have no selection criteria for the seam injection methodology. Technically, these high porosity values not correspond to the correspond to the 8 caverns formed during the cement placement and the cement drying process, as could be seen in the image of the computed tomography that was how it was presented during the investigation. And also the critical solubility temperature in water found for sodium silicate was around 300 Celsius degrees. The sample could be not get the this critical solubility temperature and remain with solubility into water at this temperature. So therefore, there is a need to make more studies on this methodology for evaluating the viability for using these methods in porous process media for thermal EOR processes. And the last one could be say that the porosity and permeability properties determined in the Sandpacks fitted with the screen criteria for the evaluation of this steam process injection in the laboratory. The computer tomography help us and show us that we have an stable degree of heterogeneity and through the all entire sample, so there is not homogeneous sample, and this is important for representing this heterogeneity that have the reservoir in the Colombia, the Colombian ones, and also there was no evidence of channeling during the fluid injection phase, maintaining a stable flow in all the sample core. So that is the investigation. These are one of the reference. And about the acknowledgement, we need to acknowledgement the Grupo de Investigación Recobro Mejorado for Universidad Industrial de Santander for the spaces and the help during this investigation, and the others that are being that me as a director am being involved in all these processes. So thank you so much, and this is my mail if you need something, and thank you for your time.